Good afternoon, ma'am. My name is Pooja Oswal and I'm going to present on topic Bayesian Belief Network. So we will understand what is Bayesian Belief Network. It is a graph-based model that helps us work with uncertainty in decision making. It shows how difficult variables in a system are connected and how they influence each other using probabilities. These networks are especially useful when we don't have any information but still want to make smart prediction or decisions. Where are BNN used? First, BNN are used in many fields like healthcare. They are used in doctor diagnosis disease based on symptoms. In finance, they can predict risk like loan default or frauds. In machine learning, they support classification and pattern recognitions. In environment studies, they can access disaster risk or population impacts. Now we will understand the diagram of belief network. So a belief network is a probabilistic graphical model that represents a set of variables and their conditional dependency through a DAC. The nodes in the graph represent variables while the edges indicates the probability relationship between them. So there are four nodes. First is A, B, C and D. The nodes of the network graph in the preceding diagram stand in the random variables A, B, C, D respectively. Node A is referred to as the parent of node B. If we are thinking about node B, which is linked to node A by directed arrow, it means A is linked to B. A is the parent of B and B is the child. Node C is independent of node A because there is no arrow between A and C. There are main two parts in Bayesian network. First is causal component, second is numerical component. Causal component, it is also known as graph structure. This shows you using a directed acyclic graph, a type of chart with arrows. Each node in the graph stands for a variable like temperature, disease, rainfall. The arrow shows which variable affect others. For example, if there is an arrow from A to B, it means A has an influence on B. Means A is the parent of B and B is the child. This structure helps us visually understand how things are connected and which one cause changes in other. Second is numerical component. It is also known as conditional probability. Each node in the network has a conditional probability table that is known as CPT. This table shows the likelihood of different outcomes based on values of related variables which are parents. This probability helps the network do mathematical reasoning and figuring out how likely an event is when other things are known. This is when the actual number live, they guide the prediction and inference. Now let us understand joint probability distribution. A joint probability distribution tells us the combined probability of all variable happening in a certain way. It simply joins the probability. In a BN, this is calculated by multiplying the conditional probability of each node given its parents. This gives us a complete picture of all possible combinations and how likely each is. Now we will see the applications of BN. First is medical diagnosis. They can predict disease based on symptoms and test results. Second is fraud detection. They can identify the patterns in banking or online activities. Third is weather forecasting, estimating the chance of rain using temperature and humidity data. Fourth is spam detection, classifying email spam or not based on keywords and patterns. Last is robot navigation. It helps robots decide their next move based on the sensors and the environment data. In conclusion, Bayesian belief network are a powerful way to think logically in uncertainty. They combine a visual model and the probability. You can use BN to learn from data, make prediction and support the decision in uncertain situations. They are trusted in both research and real world industries for solving complex problems. Thank you.